Hello class, today we're going to talk about section 8.1, the multiplication properties of exponents. So, throughout the course of chapter 8, we're going to learn about all the laws of exponents. We're going to start today with the multiplication properties. Our goal today is to be able to use multiplication properties of exponents. Let's get started. So, we are going to learn about 3 different properties today. The first one is called product of powers property. The second one is called power of a power property, and the third one, power of a product property. Now, before you panic about how similar these names are, please know that I am not going to quiz you on the names of the properties, okay? You just need to be able to use them. So, for the product of powers property, to multiply powers that have the same base, we are going to add the exponents, okay? So for example, if we have a to the power of m times a to the power of n, we keep our base of a and we add our exponents. To find the power of a power here, okay, we are going to multiply our exponents. So if we have a to the power of m being raised to the power of n, I'm going to keep my base of a, and I'm going to multiply my exponents. And my last property for today, to find the power of a product, we find the power of each factor. We find the power of each factor, and then multiply. Okay? So if we have something like this, where it's a times b to the power of m, we are going to do a to the power of m times b to the power of m. Alright? Think of it this way. You need to apply that power of m to both terms, which we'll talk about more in just a moment. Let's start by using the product of powers property. So, example 1. Our goal here is to write the expression as a single power of the base. So here's what we have. We have 4 to the third times 4 to the fifth. When I multiply two powers with the same base, I keep my base and I add my exponents. So my final answer will be 4 to the power of 8. For example 2, all right? We have negative 3 times negative 3 to the 7th power. Now here's the thing, if we just have negative 3 like that, it's actually negative 3 to the first power. So we rewrote that negative 3 as negative 3 to the first power. So now what we're doing is we're multiplying two powers with the same base. We keep my base, and we add the exponents using the product of powers property. Giving us a final answer of negative 3 to the 8th power. And we did that by adding the exponents. Now this property also holds true if we're multiplying more than two powers together. So in this case, we're multiplying y to the 4th times y to the 5th times y to the 6th. They are all powers with the same base. So what we're going to do is we're going to keep our base of y, and we are going to add all of the exponents. Okay? We did that by using the product of powers property. So, we keep our base, like I said, y. Then we just add all of our exponents. 4 plus 5 plus 6 equals 15. So our final answer is y to the 15th, which we found by adding the exponents. And that's how we use the product of powers property. Next, let's move on to our next property, the power of a power property. So example 2, we want to write the expression as a single power of the base. Same thing we did in the last example. So here we have 7 to the 3rd raised to the 5th power. When I raise a power to another power, I multiply the exponents. Okay? And that's the power of a power property. Three times 5 is 15. So my final answer is 7 to the 15th power. Okay? And we found that by multiplying our exponents. This also works if we have variables. So x squared to the 5th power. If I'm raising a power to another power, I multiply the exponents using the power of a power property. Of course, 2 times 5 is 10, so our final answer is x to the 10th power, and we found that by multiplying our exponents. So that's how we use the power of a power property. Let's look at a couple more examples. So we'll do these checkpoint problems together. Number 1. All right, here we are multiplying two powers with the same base. So I keep my base and I add my exponents. So I end up with negative 4 to the 9th power. Number 2, you need to be very careful, all right? Because we have w to the 10th, and then we're multiplying that by w, but what you need to remember is that's actually w to the 1st power. So, we're multiplying two powers with the same base. I keep my base, I add my exponents, leaving me with w to the 11th power. And then for number 3, we're multiplying 3 of them together, but we still follow the same rule, okay? I keep my base and I add all of the exponents. 4 plus 2 plus 5 is 11, so my final answer is m to the 11th power. For number 4, we're raising a power to another power, so I keep my base and I multiply the exponents, leaving me with 6 to the 20th power. This one looks a little different, but it's still the same idea. We're raising a power to another power, so I keep my base of negative 5, and I multiply the exponents, leaving me with negative 5 to the 18th power. And for number 6, again, raising a power to another power, so I keep my base, I multiply my exponents, I end up with n to the 27th. And that's how we use these properties. These 3 would be product of a power. These 3 would be power of a power. Great, let's keep moving. On to example 3. Here we're going to use the power of a product property. So this one's a little bit different. So here we have 2 times 3 being raised to the 3rd power. And what we're going to need to do here is we are going to have to apply that power of 3 to the 2 and to the 3. So we are going to rewrite this as 2 to the 3rd power times 3 to the 3rd power. All right? And what allowed us to do that is the power of a product property. Now, here's the thing. You may be thinking to yourself, all right, now we're multiplying a power times a power so we can keep the base and add the exponents. But the problem here, we don't have the same base. Since we don't have the same base, we are not allowed to use the product of powers property. So all we can do here is we can just evaluate each power. So 2 to the third power is 8. 3 to the third power is 27. Find those by using your calculator. And then 8 times 27 is 216. So our final answer would be 216. What if we have some variables thrown into the mix? Like part B here, okay? Here we have 9xy all squared. We need to apply that squared to the 9, to the x, and to the y. So this will turn into 9 squared times x squared times y squared. Whoops, not y to the y squared. All right? And we did that using the power of a product property. Now, we want to multiply these all together. All we can really do to simplify is 9 squared is 81. So we just write it as 81 x squared, y squared as our final answer. And that is the power of a product property. Now, we are going to have problems where you need to use more than one property at a time. Let's look at an example of that. Example 4 here. We want to simplify the expression 7z cubed squared times z to the 4th. Alright, let's break this up a little bit. Let's simplify a little bit. It looks really big and scary, but we can handle this, alright? First, what we want to do is we want to apply, since we have a power raised to another power, we're going to apply that squared to the 7 and to the z cubed. So I'm going to rewrite this as 7 squared times z cubed squared times z to the 4th. And that was the power of a product property. We're going to simplify that a little bit. All right. 7 squared is 49. Z to the 3rd squared, when I raise a power to another power, I keep my base and I multiply the exponents. 3 times 2 is 6. Then we still have that z to the 4th. What we did there is use the power of a power property. And the last thing we need to do is we need to simplify this z to the 6th times z to the 4th. And we do that using the product of powers property. Again, I'm not going to make you memorize the names, don't worry. All right? So, we have 49, z to the 6th times z to the 4th. We're multiplying two powers with the same base. Keep your base, add the exponents. My final answer is 49z to the 10th. All right, let's look at a couple more examples and we'll be done. All right, so number 7. What we have here, I'm going to rewrite it a little bigger. Negative 4x squared, y squared, all of that being squared. So what we're going to need to do here is we are going to need to apply this squared to the negative 4, to the x squared, and to the y squared. So, we'll have negative 4 squared, we'll have x squared squared, and we'll have y squared squared. And again, that's because that squared is being applied to every term, or every piece of the term, I should say. Negative 4 squared is 16. X squared squared, when we multiply a power, when we raise the power to another power, we multiply the exponents, so x to the 4th. And again, when we raise the power to another power, we multiply the exponents. So 16, x to the 4th, y to the 4th. Checkpoint number 8. We have 6p squared. And again, we're raising this to this power, so we need to apply this power to every piece of our term. So, 6 squared and p squared. Six squared is 36. P squared is just that, p squared. For number 9, we have negative 2, x, y to the 4th, and yet again, we're going to need to apply this 4th power to the negative 2, to the x, and to the y, to every piece. So we're going to have negative 2 to the 4th, we're going to have x to the 4th, and we're going to have y to the 4th. Negative 2 to the 4th power is 16. X to the 4th is x to the 4th. And y to the 4th is y to the 4th. And we're done. Number 10. Here we have 3a squared to the 3rd power. We need to apply this 3rd power to every piece of our term. So I will have 3 to the 3rd power. Now I have a squared to the 3rd power. 3 to the 3rd power is 27. A squared to the 3rd power. When we raise the power to another power, we multiply the exponents, giving me a to the 6th. For number 11, we're going to have to use a couple different properties. So first, let's go ahead and rewrite it. X to the 5th to the 3rd power. When I raise the power to another power, I multiply the exponents. So this will actually be x to the 15 times x to the 7th. And now we're multiplying two powers with the same base. So I keep my base and I add the exponents. 15 plus 7 is 22. And my last one. This one's kind of tough. Here we have 2wz squared to the 5th power. And we're multiplying that by wz squared. So, first, with this first term, we're going to need to apply that 5th power to every single piece. Let's do that first. So we'll have 2 to the 5th, we'll have w to the 5th, and we'll have z squared to the 5th. Then for our second term, we need to apply this 2 to every piece. So we'll have the w raised to the second power and the z raised to the second power. So let's simplify a little bit. 2 to the 5th is 32, w to the 5th, z to the 10th, because we're raising a power to another power, we need to multiply the exponents. Then we have w squared and z squared. Combining whatever we can, and I'm running out of room, we'll move that up there. We're left with 32. W to the 5th times w squared is w to the 7th. Z to the 10th times z squared is z to the 12th. And that is it. So, this concludes our lesson on 8.1. Go ahead and give the homework a try and email me any questions.